Using our point slope form, okay, what we're going to do here using our point slope, we're going to take the components that we have. As we said, with lines which are parallel, lines which are parallel, the slope's going to be exactly the same. So we know that our m is going to be equal to 2, for the other line as well as the original line. So then I'm going to take the components that I do have, which is my ordered pair, in -3, +5. I'm going to plug that into point slope form. So just like what you guys did on your last homework assignment. So I go y minus y1, which is 5. My slope, which is 2. X minus x1. So x1, which is -3. Of course, anytime we have the double negative, that just becomes plus positive. Okay, so now I have it in point slope form, but what are they asking us for? Yeah, slope-intercept form, right? Okay, so we need to get it into slope-intercept form. What does that mean? Okay, well, what's our objective though? We ultimately want to do what? Ultimately, we need to isolate the y. Okay, that's our objective. So yeah, okay. So Cooper, how do we start off?
Distribute the 2 to x and 3.
Exactly. So we're going to start off. We're going to distribute the 2. We're going to simplify to begin with. Okay. All right. So once I do that, I distribute that 2. Still need to isolate the y, so we just really have one more step on this one. We're going to add the 5. Okay. Combine like terms. Okay. And specifically for this one, we did know that the slope was going to be exactly the same. So y is equal to 2x, but we did need the y-intercept as well. So for this one, the y-intercept would end up being positive 11. So if we were to sketch the graph on this one, we'd start at 11, then we do our slope 2 over 1, or negative 2 over negative 1, and we have our parallel line. Okay, any questions on that? So this not only gives us our slope, but it also gives us our y-intercept. Okay, so I'll just go through that one more time. Okay, on this one, we just plug in our numbers. So we have the 5, plug it in for the y1, -3, plug that in for the x1. Of course, that becomes positive. We've got our slope. Okay, so we take our slope from the other line, which is 2. Then we simplify, and once we simplify, we isolate the y, and that gives us the form that we need. Okay, so I'm going to give you all a couple of these to try. Okay, we have 4, -1. And the line that we do have is y is equal to 1/4 x plus 7. I'll tell you, I'm just going to give you all one. I'll give you another one here in just a second. Okay, what you're going to need to do, once again, these are lines which are parallel. Okay, determine what would be the linear, or what would be the form, slope-intercept form of the other equation, which would be parallel to y is equal to 1/4 x plus 7. Do this particular one. So using our point slope form, we're going to plug in each of our components once again. So we end up with y plus 1 is equal to 1/4 times x minus 4. Okay, so once we plug those in, simplify once again, distribute the 1/4. And isolate the y. So on this one, we isolate the y, we get -1, then we get y is equal to 1/4 x minus 2. So as we said before, of course, we know with our lines which are parallel, the slope is going to be exactly the same with parallel lines. Okay? No, all these. Okay, let's do one more of those. Okay, try this one. Okay, this time we have y is equal to 1/2 x minus 7. Okay, with an ordered pair of 4, -2. And once again, lines are parallel. Okay, so let's go through this one. So on this one, like last time, we're just going to plug in each of our components. So for this one, our slope, of course, is going to be the 1/2. So we say y minus, and then we have -2 for the y coordinate, so it's going to end up being +2. Okay, slope is 1/2. Okay, x coordinate, which is 4. Okay, distribute the 1/2. And subtract 2. Okay, so we end up with y is equal to 1/2 x minus 4. So once again, that is the line which is going to be parallel. Okay, these two are the two lines which are parallel. Okay, all right, any questions with parallel lines? Okay, so at the beginning of the lesson, it said that we're going to look at how to find lines which are parallel but also perpendicular. So what does that mean if lines are perpendicular? Okay, they intersect, but specifically, okay, they have a specific angle. If they are perpendicular, 90 degrees. Okay, perpendicular lines are going to be 90 degrees, or right angles. Okay, so, okay, what I want y'all to do on this one, actually I want to use this one. Okay, using this one here, okay, -2 and 3. This is your equation, y is equal to -1/2 x minus 4. And once again, you are determining lines which are perpendicular this time. So now determine, okay, by graphing, okay, use your graph paper. See if you can figure out, go ahead and plot this one first. Okay, go ahead and sketch that graph. And then once you sketch that graph, okay, using this ordered pair, -2, +3, see if you can determine, okay, what would be the line which would be well, at least find the slope. Okay, that's what you're really looking for. Okay, what would be the slope of the line perpendicular to this one? Okay, so let's take a look, because this is what you really have to, this is what you have to understand for these. Okay, how do we do this algebraically? The only reason I showed you graphically, just so you could visually see, okay, how lines are parallel, how lines are perpendicular, but really algebraically is what you need to understand. So as we just talked about with the slope, okay, the slope has to be opposite reciprocal. Okay, it has to be opposite reciprocal. Once again, opposite is in reference to the sign. Reciprocal, of course, is talking about flipping the fraction. Okay, so for this one, because we just looked at, okay, what would be the slope that we would have to use? +2, right? Okay, so +2, 2/1. Of course, we simplify that, we get +2. Okay, so going back to our problem here, so how do we do this algebraically? Well, just like what we did with the lines which are parallel, we're going to use our point-slope form. But this time, instead of using the exact same slope, okay, what you're going to use the opposite reciprocal. Okay, so for this particular one, of course, it's going to be 2. Now, we'll still use the ordered pair, okay, which is given, which is -2, +3. So just do y minus, go to y1, which is 3. This time, our slope that we're going to use is 2. That is the opposite reciprocal to the original, okay, our original being the -1/2. Then we have our first x coordinate, which is a negative, becomes positive. Now, once we get everything plugged in, okay, we just need to isolate the y. All right, so specifically on this one, of course, we already knew the slope, but we had to find of course, the y-intercept, which would be 7. Okay, all right, so, because we already looked at, it's opposite reciprocal for that. On this one, okay, write an equation in slope-intercept form for the line that passes through 7 and is perpendicular to y is equal to 2/3 x minus 1.
Wait, can we just write that out like you did a minute ago and just put like perpendicular?
Okay, class, so once again on these, you're going to have to use the opposite reciprocal since you're dealing with a perpendicular line. So, okay, using our point slope form, plug in our numbers. So, of course, we got 4, 7. So, plug in the 7 for the y, plug in the 4 for the x1. And, okay, our slope here is 2/3. If it's going to be opposite reciprocal, this will be -3/2. Okay, then, of course, we just distribute that. And then isolate the y, add the 7, so we end up with y is equal to -3/2 x plus 13. Now do remember with slope, can't make that a mixed number, so you have to leave it as improper. Okay, all right, any questions on that one? Okay, we got one more we're going to have y'all try. Okay, this time we have an ordered pair of 2, 3. But this time with the equation, what's different with the equation? It's in standard form. So what do you have to do first? You got to isolate the y. Okay, you have to put it in slope-intercept form to begin with on this one. Then once you put it in slope-intercept form, then you just go through the same process. Okay, class, let's go through this one. Okay, on this one, of course, we start off with our ordered pair of 2, 3, and then, as we talked about, this is in standard form. So, of course, you have to isolate the y. So, when you isolate the y, this is the equation that you should get. So, we see our slope is -2/3. So, of course, we're going to use the opposite reciprocal of -2/3, which is 3/2. And we distribute the 3/2, so you should have 3/2 x minus 3. Now, the thing is, when you add the 3 from this side to this side, of course, it's going to cancel out. So you don't put +0. You just write that as y is equal to 3/2 x. Joel?